Hi everyone, we are the Cameraless Motion Capture Group, and the general project idea is that we want to use a IMU based arm motion capture system to accurately model the arm's movement. As you can see in the image on the right, the general idea is we want to place these IMUs at relatively key points on the arm so that we can do arm tracking using the initial data captured by the IMU. We then use this data to model and simulate a two-linkage arm model, and potentially can use this to do some analyses of the sixth degree of freedom joint motion and other ideas that we will further expand on.
So for our hardware components, we are going to use a microcontroller to do all of our programming on. This could be like a Raspberry Pi or a Arduino Uno. We're going to power that microcontroller with a battery and then attach two IMU sensors to get initial values from that. So the initial pose is going to be just like a person T-posing, and that's how it's going to know where they're starting from. And the IMU is going to be attached one to their elbow and then the second one to their wrist.
So the applications of this are mainly for the user to be able to analyze and practice their arm movements for whatever sport they're doing. So this could be like perfecting a golf swing, a baseball swing, any sort of racket sport, your boxing punch, for example. And then some feature, or next slide, please. And to do this, we're implementing a few features. We might not implement all of these, but this is kind of a general idea of what we're trying to accomplish. So the first one is the real-time motion tracking of the arm. So this way we can see what the arm looks like a virtual version of it on the computer, see all the different angles and play it back in slow motion. The other one is, and during this, we can also look at our range of motion for whatever it is we're tracking. Then after that, it'd be nice to have a feature to track our consistency so we could measure the error of our motion relative to some reference. We could also add more IMUs to the wrist and shoulder, for example, to get a higher fidelity model of our virtual arm. And lastly, with all this data, we could implement another software feature to get speed and power analysis on whatever motion it is the user is doing.
And finally, here are the learning outcomes we hope to achieve by doing this project. The first is using the Kalman filter and data smoothing in order to enhance the accuracy of our motion tracking by filtering our noisy data. The second is using kinematics and geometrical constraints to model the arm movements, kind of what Lauren says with also the analysis of motion. The third is using embedded programs using microcontrollers, and this will help us facilitate this kind of real-time processing in like a portable form factor. And finally, data visualization, which allows us to consolidate all our data in like very easy to see visual aids, aiding in like quicker and more effective decisions.